Okay, so right now we're going to walk you through the proofs of the multiplication and division rule and de Moivre's theorem. So, unfortunately, in order to prove these two things, you need what's called a trig identity. So, specifically, we're going to be using what's called a sum and difference identity. So, the sum identity for sine and cosine looks like this. So, sine of theta plus 1 plus theta 2 is looking like this. Sine theta 1 cosine theta 1, or excuse me, theta 2, plus sine theta 2 cosine theta 1. Okay? The difference identity looks like this. So sine theta 1 cosine theta 2 minus sine theta 2 cosine theta 1. Okay, so that's the sum and difference identity for sine. The one for cosine looks like this. Cosine theta 1 plus theta 2 cosine theta 1 times cosine theta 2 minus sine theta 1 sine theta 2. And then the one for the difference, cosine theta 1 cosine theta 2 plus sine theta 1 sine theta 2. Okay, so please notice that they do use these formulas in the Edgenuity proofs. Okay, they are considered identities, they are formulas. Right, for our purposes, we're going to take them without proof. Okay, and maybe later on in the school year, we'll work on proving these identities as well. Okay, so let's start with the multiplication formula. Okay, so I'm just going to walk you through the formula, hopefully give you a little bit more detail than you saw in the video instruction from the Edgenuity. Okay, we are going to have to refer back to these formulas up at the top, so please keep those in the back of your mind. Okay, so if I want to multiply two polar form complex numbers, we're going to start out with z1 equals r1 times cosine theta 1 plus I sine theta 2. Then z2 r2 cosine theta 2 plus I sine theta 2. And I just wrote, that's a theta 1. Sorry about that. Okay, so now we're good. Okay, so we want to multiply these two things. Okay, so we're going to go z1 times z2. Okay, so we know what z1 is and we know what z2 is, so let's write those in. Here's your z1. Here's your z2. Okay, so these are all multiplication. So I know, because multiplication is commutative, that I can rearrange it. So what I'm going to do is I'm going to move these, the two radii or the two moduli, to the front. Okay. And then move the parentheses terms to the back. Now remember, this is a multiplication problem, and even though it says sine, cosine, and it looks really complicated, this is basically right here. Okay, these are two binomials, so you're going to use the distributive property to multiply. Okay, so you can call it distributive property, you can call it FOIL, whatever you want, but that's essentially what you're doing. So we're going to keep that modulus in the front. And now we're just going to multiply. So cosine theta 1 times cosine theta 2. Okay, I'm going to multiply. So I'm going to put the I in the front. I cosine theta 1 sine theta 2. Okay, now I'm going to do the second. So plus I sine theta 1 cosine theta 2. Okay, and then the one after that, last one. I times I, remember, is I squared. Okay, sine theta 1 sine theta 2. Okay, so now we're going to look inside those parentheses and see if there's anything that I can maybe simplify or group together. Okay, so what I'm noticing is that the two middle guys have eyes. So I'm going to keep those together. And what I also notice is that this guy right here, that's an I squared. So I can change that to a negative 1. So what I'm going to do is I'm going to do some rearranging. I'm going to keep the R1, R2 in the front. Now, anything without an I is going to be moved. So cosine theta 1 times cosine theta 2. And remember, your I squared turned negative 1. So minus sine theta 1 sine theta 2. Okay. Now, anything with an I, I'm going to move to the back. Like that. Okay, so now notice that these both have eyes. Oops. So what I can do is I can bring out that eye by factoring and make it look a little different. So now we're going to bring out that eye. Okay, so now is the time where we're going to bring in those sum and difference identities back up at the top. So if I notice that this one, we have two cosines in the front, a subtraction sign, two cosines in the back. So looks like cosine theta 1 plus cosine theta 2. So all we're going to do is substitute. Okay, now this one here, okay, that one we have a cosine theta 1 sine theta 2 plus sine 1 cosine theta 2. Okay, that one looks like sine theta 1 plus sine theta 2. Okay, well, it's a little different, but we can switch it around because it's multiplication. So, hey, we can do another substitution. And now that looks like my multiplication formula. Okay, so now let's talk about division.